Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on fractional indices. So now we're looking at examples where the index or the power is a fraction. So let's say we have something like 4 to the power of a half. Well, once again, doesn't really have a natural meaning. We can't times 4 by itself half the time. You can't do that half the time. So what we're going to do is define this so it's consistent with other index laws. So I know that if I square this, I keep the same base and I multiply the powers together. A half times 2 is 1. So if I square it, I get 4. So what then is 4 to the power of a half? Well, 4 to the power of a half is the thing that you square to get 4. What do you square to get 4? Well, that's actually 2. 4 to the power of a half is 2. Okay, so did we just go 4 times a half? Let's see if it works for another number. So let's say I have 9 to the power of a half. So if I square that, I get 9. Half times 1 is 1. We multiply the powers together. So 9 to the power of a half is the thing that you square to get 9. What do you square to get 9? Well, of course, the thing you square to get 9 is 3. So 9 to the power of a half is 3. So hopefully you're seeing that because if I raise a to the power of a half to the power of 2, if I square it, I just get a. But the thing that you square to get a is the square root of a. So raising something to the power of a half is the same as square rooting it. Just like 9 to the power of a half gave us the square root of 9, and 4 to the power of a half gave us the square root of 2. So we have this rule that a to the power of a half is equal to a. But what about other indices? We don't always just have a half as the fractional power. I mean, there are other fractions than a half. So what about a to the power of 3 on 2? Well, to be consistent with the power to power rule, that's a to the half to the power of 3, because a half times 3 is 3 over 2. So a to the power of a half is the square root of a, and we're just cubing that. Note that that is exactly the same as this. These two are exactly the same thing. So what about if we have a different denominator other than 2? Let's say we had something like a to the power of a quarter. Well, I know if I raise that to the power of 4, I must get a. But the definition of the thing you raise to the power of 4 to get a is the fourth root of a. So the fourth root of a is saying, what do you times by itself 4 times? In other words, what do you raise to the power of 4 to get a? So we have a to the power of a quarter is the fourth root of a. So what would be something like a to the power of 3 quarters? Well, that is a to the power of 1 quarter, but raised to the power of 3, to be consistent with the power to a power rule. But this in brackets is the fourth root of a. So this will be the fourth root of a cubed. Okay? So raising something to the power of a half is square rooting it. Raising it to the power of a third is cube rooting it. Raising it to the power of 4 is fourth rooting it, and so on. Let's come up with a very specific and formal rule. So our index law is that a to the power of b over c. This bottom number tells you which root of the base to take, and this top number, the numerator, tells you which power we have. So remember, the cth root of a is just saying what do you multiply by itself c times to get a. So for example, the fifth root of 32, there is a button on your calculator, but we can do it without a calculator. It's saying what do you times by itself 5 times to get 32. The answer is 2, because 2 to the power of 5 is 32. The fourth root of 81 is 3, because 3 to the power of 4 is 81. It's saying, what do you times by itself 4 times to get 81? So let's look at some concrete examples, and hopefully this will be a bit more clear. So let's say we have something like 8 to the power of 5 over 3. So by our index law, 3, the number on the bottom, is which root to take, so we're taking the cubed root of 8 and raising it to the power of 5. Now, when I'm figuring this out without a calculator, I probably don't want to do 8 to the power of 5 in my head. That might take a bit too long. So it doesn't matter the order you can do it. I can find the cube root of 8 first and then raise it to the power of 5. So the cubed root of 8 is 2, because 2 cubed is 8. So this is just 2 to the power of 5, which is 32. So let's have something like 25 to the power of 3 over 2. So our index law, that is the second root, which is the square root of 25 cubed. Of course, if I'm doing it in my head, it's probably easier to do the square root of 25 than cube it. Square root of 25 is 5. 5 cubed is 125. So let's now look at some examples involving just pronumerals. So we're going to write each of the following as a radical. So a radical means it has a square root or a cube root or a fourth root or something like that, some sort of root. So remember, the thing on the bottom of the fraction tells you which root to take. So this will be the fourth root, and then the thing on the top tells you the power. So this will be the fourth root of x to the power of 3. So let's look at the next one. You might be thinking, okay, what's the difference between them? Well, we've switched around the numerator and the denominator. So in the second one, 3, which is on the bottom, goes on the outside, and 4 goes on the inside, okay? So the number on the top goes inside the root, the number on the bottom is outside the root, if you like. So then let's do the third one. So this is 3 times y to the power of 7 over 2. So y to the 7 over 2, this tells you which root to take. Well, the second root is the square root, and then the 7 goes inside, okay? So I just want to make sure you know the difference between writing like this and writing like this. If I have something like 3 times root x, we write it like that. That means 3 times root x. It means square root x, get your answer and times by 3. But if you put the 3 as part of the radical, that means the cubed root of x. That means you're saying, what do you multiply by itself 3 times to get x? And now we're going to do a few more examples that also incorporate other index laws. So let's now do these 3 examples. So now we have a negative power. So the negative power rule still works. Things with a positive power go on top, and then things with a negative power go on the bottom, but you write them with a positive power. So we know x to the power of 2 over 5 means the 5th root of x squared. So that's our final answer. Let's look at the next one. So we still have our 1/3, and we write this thing with a negative power on the bottom of the fraction, but change the power to positive. So we know that z to the power of 7 over 8, so that's 8th root of z to the power of 7, and we're done. All right, for the last one, we're going to need the fraction rule and the power to a power rule. So we raise the top to the power. So that means we keep the same base, A, but we multiply the powers. 1/3 times by 3 is 1. So this is A to the power of 1. And on the bottom, we have B to the power of 2 over 5 times 3. So we can leave the A by itself. It doesn't need a radical. But what goes on the bottom? It's the 5th root of B to the power of 6. Remember, because 5 is on the bottom, it's the 5th root, and 6 is on the top, it goes inside. All right, now we're just going to do a few quick examples where we're going the opposite way, starting with a radical and ending with a fractional power. Please pause and copy this down if you need. Let's look at these 4 examples here. Now we're just going the opposite way that we were. So let's look at the first one, the 7th root of x to the power of 5. We know that we have our base. The power, the thing inside the root, goes on top, and which root it is, in this case 7, goes on the bottom. How easy is that? Similarly, for the second one, we have our y, so the power inside the root goes on top, and which root it is goes on the bottom. So if we look at the next one, well, that will just be 1 over square root of x is just x to the power of a half, or if you like, that's the same as x to the power of minus a half. So the last one's a bit tricky, have to use a couple of index laws. So it's probably easiest to convert to fractional powers anyway, and then perform the multiplication. So we have minus 2 over, so this thing on the bottom, it would be x to the power of 2 goes on top, 3 on the bottom, and then this one here, it would be x to the power of 8 over 5. So what we're doing here is dividing. This is the same as minus 2x to the power of 8 over 5 divided by x to the power of 2/3. So remember, when we're dividing bases, we keep the same base. So we're going to leave our minus 2 as it is, but we're going to keep the same base and subtract the powers. 8/5 minus 2/3. And you can use your calculator for that. If you like, you should get 14 over 15. And then we're done. All right, I know this was a bit abstract and tricky. You're a superstar if you get it. I'm really proud of you. Thank you so much for watching this video. This has been the luckiest maths teacher in the world. Have a great day.